So good morning, everyone. This is Circular Dynamics lecture number 6 for NEET, and we have been doing pretty well with circular dynamics. Lots of concepts have been discussed till now. In the previous class, which was a very important class, Circular Dynamics lecture number 5, in that particular class, we had discussed how are we going to solve question on circular dynamics, and we had seen a series of steps, and I told you that are very important. Those steps are very important for you to understand, so I'll just go through those steps once again for a quick revision so that we are at pace with what is going to happen in this class. We will be solving problems based on the steps that we have already discussed. So what were those steps for solving problem in circular motion? Basically, in circular dynamics is what we are talking about. The first step is, and always will be, draw the free body diagram showing all forces acting on the body. Remember, my kids, remember, bacho, in NEET, you may not have so much time to do this. In NEET, the question would be pretty straightforward, but you need to know the basics because there might be a question there might be a question which requires there might be a question which requires more understanding, might be a difficult one, and there you might be needing all these steps. In NEET in general, the question would be very straightforward and you would not need to do so many things. Straightforward question, and I'll go through those questions very quickly and you will see that. First is draw free body diagram. Second is resolve all forces along three axes, and we have talked about these three axes. The first axis is along the tangent in the direction of motion. Body is moving in a circular path. The direction of velocity is always tangential. Please remember that it is always tangential. So this is in the direction of motion. One is along radial, or you can call it towards the center, centripetal direction or radial direction or normal direction. And the third one is perpendicular to the plane of circular motion. If the circular motion is happening in this plane, the perpendicular direction is this one. If the circular motion is happening in this plane, the perpendicular direction is this one. If the circular motion is happening in this plane, the perpendicular direction is this one. I hope all of my kids understand it. So these are the three directions in which you have to make equation. In NEET, you might not require, because the question would be based on a pattern, simple patterns, and we will discuss those patterns one by one. So if any question comes from that pattern, and it will come from that pattern, you can straight away write the answers with your previous knowledge. Then what you got to do again, this part of the steps may not be required in NEET. Very hard, very seldomly you will require it, very less you will require it, but still we can go through this. Then you have to make the force equation. Force along the tangential direction must be equal to m into at. That will give you a tangential acceleration. Force along the centripetal direction will give you m into ac, and m into ac will come m into vt square by r, or m into omega square r. From here you can get the value of v or omega or acceleration or whatever you want. There is no motion that is going to happen in the perpendicular direction, and hence the whatever forces are happening in the perpendicular direction, whatever forces are there in the perpendicular direction, they will balance each other out. Upward force will be equal to downward force. Inside force will be equal to outside force. Right side force will be equal to left side force, depending on which is your perpendicular direction. Then the fourth step is, if the number of equations are less, you might have to use work energy theorem or Locke-May. You would hardly require this because I'll give you set patterns. You would hardly require this. Then you have to solve questions. Remember, you have to solve equations and then get an answer. In the case of NEET, you might not have to do this. Again, I'm repeating myself. but I must make this point clear that the question would be pretty straightforward. Now, we are going to study this circular dynamics under two headings. Two types of motion. Under two headings, we are going to study the circular dynamics. The first heading would be motion in a horizontal circle, and that is the heading that you are going to write. First of all, the first motion is motion in a horizontal circle. Motion in horizontal circle. Motion in a horizontal circle. So circular motion will be in a horizontal circle. Instead of calling it as horizontal circle, you can call it motion or circular motion in horizontal plane. You can also call it circular motion in a horizontal plane, depending on how you understand it, how you call it. Nothing in a name. Horizontal plane. Motion is going to happen in horizontal plane. Now I would like to ask you, what do you understand by a horizontal circle or motion, circular motion in a horizontal plane? What is a horizontal plane? Will anyone tell me that? Online class, offline class? Only Abhiram is there in the online class. Rest of you are in the offline class. Any idea what is horizontal circle or what is circular motion in a horizontal plane? What do you mean by horizontal plane? Anyone can tell me that from the online class or the offline class? What do you mean by motion, circular motion in a horizontal plane? Well, if I just tell you, if I just try to make you visualize it, I can vaguely draw three planes in space. I mean, I can draw infinite number of planes, but I can always draw three planes which are perpendicular to each other. Three dimensions of space, three planes I can draw, three perpendicular lines I can draw which are perpendicular to each other. We call them skew lines, three dimensions of space. So I can draw three planes. One is this plane. The other one is this plane. The other one is this plane. Now, you might be sitting in a room. So if you want to understand the planes, look at the wall which is in front of you. That is plane number one, front facing. Look at the wall which is on your side, right hand side or left hand side, plane number two. Look at the ceiling or the floor, plane number three. And look at the corner. You will see all these three planes intersecting at a corner. You can call that as origin. You can call that origin on the top corner. You can call it on the bottom corner. You can call it bottom right. You can call it bottom left, whatever. These three planes will be meeting at one point. You can call that as origin. One is XY plane, one is YZ plane, and the other is XZ plane. 1, 2, 3. Now, when we are discussing this circular dynamics, circular motion, basically we are going to study circular motion on Earth, on the planet Earth. We are not going to study motion of satellites or moon around Earth. We are not going to study the motion of Earth around Sun because that is in gravitation. That is not circular also. Only the motion of moon around Earth is circular, and these artificial satellites are moving in circular motion. Apart from that, everything is elliptical. The motion that we are going to study in this particular chapter here in work point energy circular dynamics, we will be studying motion of particles on Earth. Now, when you are studying the motion of particles on Earth, circular motion of particles on Earth, and when I say that the motion is in a horizontal plane, what do I mean by that? Why do I have to study it in a horizontal plane? Remember, when we are on Earth, anybody on Earth or very near to Earth is experiencing a force by Earth, and that force is gravitational force. And for simplicity, for small beings like us, the gravitational force is acting vertically downwards. The gravitational force, which is mg, mass into acceleration due to gravity, is acting vertically downwards. Now, wherever the motion is happening, this gravity force is always downwards. Vertical plane, gravity force is downwards. This plane, gravity force is downwards. Wherever the motion is happening, this plane, gravitational force is downwards. Doesn't matter. All beings experience gravitational force in the downward direction. It is not in the downward direction. It is towards the center of what? It is not towards the center of what? It is somewhere otherwise. And we will understand that in gravitation. But for simplicity, it is acting downwards. Now, when it is acting downwards, now I can call planes as vertical plane or horizontal plane, depending on, because gravitational force is acting downwards. Gravitational force is acting along the vertical plane. And that is why horizontal motion, motion in a horizontal circle, motion in a horizontal plane becomes important. Which one will be called as horizontal plane? One plane is this, front wall. One place is this, one plane is this, side wall. One plane is this, your ceiling or your floor. Which plane is horizontal? Which plane is horizontal? Tell me. Which plane is horizontal? Anyone? No one in the online class? No one in the offline class knows which is horizontal plane? Three planes. This one, front wall, side wall, ceiling or floor. Which is the horizontal plane? And yes, the correct answer is this plane. Your ceiling wala plane or your floor wala plane or the surface of earth wala plane. That is the plane that we are talking about. That is known as the horizontal plane in Earth's gravity, or that is the plane that we are calling horizontal plane, and we are going to study circular motion in this plane. Do we all understand this? Can I have some reason that we understand this? That this is the plane in which we are going to study circular motion. So any motion which is happening on ground in a circular path, that is example of motion in a horizontal circle. If this is a book and a small block is moving on this book like this, I hope you can all see this. This is motion in a horizontal circle. A car or your cycle or your bike turning on road, curved road, and your car and vehicle is turning on that road. That is motion in horizontal circle or motion in a horizontal plane. Any motion that is taking place on the surface of earth or any plane which is parallel to the surface of earth. For example, any motion that is happening on this table. If this is the table, this is a tabletop, and something is moving on this tabletop, horizontal circle, horizontal plane. That is the motion that we are going to study. Do we understand this? Can I have some reason that yes, sir, we understand this? Motion in a horizontal circle or motion in a horizontal plane. So any example, anything that you can think of moving on the surface of earth in a circular path or in a zigzag path. I also told you any zigzag path is circular path at any point. That is the example of motion in a horizontal circle. How are you going to solve problems on this? Again, the steps are same. Draw free body diagram, resolve the forces, write the equation, solve them, and we are done. So any motion that is taking place on the surface of Earth is motion in a horizontal circle, and we are going to study this motion. How are we going to study this motion? Very simple. We are going to see some examples and remember them. And if any question comes, don't have to solve the entire question. If you remember if you remember this is NEET, this is not JEE. If you remember in which category, which motion it lies, you can straight away give your answers without solving the question, because NEET physics is pretty simple. It's pretty straightforward. It just depends on whether you know the formula or not. But you should also know the concept, because there can be questions as in last year's paper which requires a bit of conceptual understanding as well. And that is why I'm giving you everything that you must know in short. That is the beauty of this class, that we try to do whatever I think these people can give you in an examination hall. So we'll go and do the first problem on motion in a horizontal circle, and the problem is coming on your screens right now. And the problem is pretty damn simple. Once you have done this problem, any problem that comes in this way, you can straight away give the answer. This is a problem of horizontal circular motion, and this is how it can be solved. So let me read out the problem first, and then we can discuss it and see how it has to be done. A block of mass 2 kg. Now instead of calling it as 2 kg, let me make the question general and let me call the mass as m. A block of mass m is tied to a string of length, instead of 2 meter, let me call it as L. So a block of mass m is tied to a string of length L. The other end is fixed. One end is tied to a block, the other end is fixed. Obviously, it is going to move. The block is moved on a smooth, so there is no friction, horizontal the table on which you are writing, with a constant speed 5 meter per second. Instead of calling it as 5 meters per second, let me call it as V. A block of mass m attached to a string, moving on a horizontal table with a constant speed V. You have to find the tension in the string. That is the problem. I'll give you a minute to think about it, to solve it, and I'll be back with the solution and your answers after a minute. Think about this problem, apply conceptual steps, and if you can do it on your own, congratulations, you have done exceedingly well. So I'll be back after a minute. I'll give you time to solve it. Okay, let me solve this problem for you. So this motion is happening on a horizontal table. Now, if I take this as a table, the motion is happening like this. Now, if the motion is happening like this, now how I'm going to draw this on this sheet? How I'm going to draw this is like this. I am first going to make a table. So this is my table. Now, as soon as I make the table like this, the plane, this becomes my vertical plane. I hope you understand that. This becomes my vertical plane. Now, this motion is not happening on a vertical plane. This motion is happening on a horizontal plane. Now, the horizontal plane, if the vertical plane comes on the sheet or on your books, and the vertical plane goes in and then the horizontal plane goes in and out. So if now I have to draw the horizontal plane, the circular motion in the horizontal plane will look like this. I will have this string attached to a block of mass m, and now it will be moving. How it will be moving? It will be going in, then coming here, then coming out, then in, then out, then in, then out, and the motion is going to happen in this way. So the motion will be happening like this. It will go in, then come out, then go in. Do we all understand this? How this motion is going to happen? It will go inside the board, then it will come out, This is how the motion is going to happen, and this is how I can show it. That is the only way I can show it for you to understand this. Do we understand what is happening here? How I have drawn the diagram? I have drawn a table. When I draw the table becomes the vertical floor, the vertical plane, and then I have to show the horizontal motion like this. I'll have to show the horizontal motion like this. Now, if I talk about the three directions here, the direction in which the horizontal motion is happening, that is my tangential direction. So this direction where the horizontal motion is happening, this becomes my tangential direction. Do we all understand this? This becomes my tangential direction. Now there is no force on this tangential direction. So the net force on this tangential direction is zero. There is no force. So I cannot make any equation in this tangential direction. Do we all understand this? Can I have some reason that we understand this, sir? That no equation can be made because there is no force. There is no force, no tangential force, so there is no need for any equation. Now if I talk about the second direction, and I will draw it by green, the second direction is the centripetal direction, or towards the center. If I look here, the center O is here, and this direction becomes the centripetal direction towards the center. There is only one force acting in this direction. There is no friction, remember. There is only one force which is acting in this direction, and which is that force? And that is the force because of which this particle is moving in the circular path. If there is no force, then this particle cannot move in that circular path. This particle is moving in the circular path because of the string. It is attached to a string, and that string is attached to a point, and because of that string, that particle is moving in a circular path. That means that string is providing it with some force which is making it move in the circular path. Now my question is, what is that force? The force which the string applies on this block so that it moves in a circular path. And the answer is very simple. The answer is, sir, it is the tension T. Tension T is the force, only force which is acting towards the center, moving in a circular path. Tung, 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 tung. So wherever it is, there is always tension in the string which is always trying to pull it towards the center and make it move in the circular path. Do all of you understand this? I have only drawn one point of the circular motion. I have not drawn the entire circular path because I just can't draw the entire circular path because it is coming in and out of the board, in and out of the book, in and out of my tablet. Do we all understand this? Can I have some reason that we understand this? The way that the book has drawn this diagram, they have drawn the entire circle in the vertical plane. And if you draw it entire circle in the vertical plane like this, you might get confused because you can always draw gravity which is going like this, and that gravity will make your concept of understanding this question difficult. And that is the reason I have not drawn the vertical plane. I have drawn it on the horizontal plane. Do we understand this? Can I have some reason that we understand this? How I have drawn the diagram? What are the forces acting here? There is no force in the tangential direction because there is no friction. Nothing acts in the tangential direction. The only force that is acting in the centripetal direction is is your your tension force. Do we all understand this? Please raise your hands and let me know that we understand this, sir. Abhinav understands this. What about the others in the offline class? I'm waiting for your signal. I'm waiting for your signal. Once you give me your go ahead, then only I will move ahead with this question. Offline class, my students in the offline class, am I clear with this explanation of what I've done here? I hope you all can raise your hands. Somehow someone can do that for you. I can't see you guys. That is a problem. But still, if you can let me know that you have understood this concept, students in the offline class, I'm waiting. Again, I will repeat. The tangential direction is along the surface of this book. There is no force acting along the surface of this book. Frictionless path, smooth path, and hence I cannot write any equation in this direction. The tension in the string is always acting towards the centripetal direction, radial direction. That is the only force acting along the radial direction or towards the center. Do I have concurrence from you sitting there on the other side of the screen in the offline class? Do we understand this? No one can give me an answer? Well, if there is no answer, I'll assume that this is a yes, that we have understood this, else you will ask your doubts, no doubt. So the only force that is acting in the toward the center is T. So now I will make the equation along the centripetal direction. The equation along centripetal direction is F centripetal, whatever is the net force, must be equal to M into V square by R. Now the centripetal force, the force which is giving you the centripetal force here is only one force, that is in the radial direction, that is T. So this T would be equal to M into V square by the radius of this circle. The radius of this circle is nothing but equal to the length of the string. So my T becomes the green equation, the centripetal equation becomes T is equal to mv square by L. And that is the answer. That is what they were asking in the first place. How much is the tension in the string? And the answer is simply mv square by L. Do we all understand this? Can I have some raise hand that we understand this? Aviram has understood this. What about the students in the class? Can I have some confirmation from you guys as well? Okay, fine. Now, what remains to understand or be understood in this question, which is not asked in this question, but you need to understand it. There might be a question where they ask that. We have talked about three directions, three axes that we have to make equations. Three. Along the tangent, the red equation, there is no force in this question. So there is no force, you cannot draw anything. Along the centripetal radial, you will always have force in this direction because we are studying circular motion. So you will always have one equation that will come in the centripetal direction. The net force in the centripetal direction must be equal to mv square by R. This is what we have done, and that has given us the answer for this question. But the third one remains. The third one remains. The perpendicular direction in which the circular motion is happening. What are the forces in that direction? Remember, I told you that in whatever direction the circular motion is happening, in the perpendicular direction, no motion is happening. Right now, the motion is happening on this plane. The perpendicular direction is like this. This is upwards and this is downwards. No motion. The motion is happening here on this plane. There is no motion happening in this perpendicular direction. And therefore, the net force in this perpendicular direction must be zero. The net force in this perpendicular direction must be zero. There is also no force in the tangential direction. So it is zero. But the net force in the perpendicular direction should always be zero. Now, what is the perpendicular direction here? And if you look closely, the vertical is the perpendicular direction here. The motion is happening on this plane. So this direction is the perpendicular direction. Now think about what are the forces in this perpendicular direction. If there are forces, they must balance. If there are forces, they must balance. Now, can you tell me, we have not drawn the full free body diagram. There are two forces which are missing here. Can anyone point out what are those two forces which I have not drawn on this block of mass M? There are two more forces acting on it which I have not drawn. Can anyone tell me what are those forces that I have not drawn? And without even drawing those forces, I was able to solve the question. I was lucky. I was not lucky. I knew that those forces are not required. I've been teaching for long, so I know that those forces are not required to solve this question. But two forces I have not drawn. Can anyone point out what are those two forces? Abhiram, anyone in the offline class? I understand that for the offline students it's difficult to respond, but that should not happen. If your mic is not working and if I can't see you, if you can't respond, it becomes a difficult thing for me to make you understand what is happening in the class. So I would request whosoever is there to work on that mic, work on the camera as well. There's no camera, I don't understand. I don't see anything. Okay, what are the two forces that I have not drawn? No one knows it? Well, old forces, again coming back. They are not old forces, they are no old and new forces. Forces are always there. The only thing is we must remember that we have studied them. The first force is the normal reaction coming from ground, and normal reaction coming from ground. And the second force is the weight, which always acts in the vertical plane. It is always vertically downwards, and this is equal to mg. Can't change it. Now there is no motion happening in this perpendicular direction. Perpendicular to the plane of the motion, forces must equate. In the tangential direction, just understand the difference between what is happening in the tangential direction and what is happening in the perpendicular direction. In the tangential direction, there is no force. If there is no force, it is zero. Tangential direction, no force, no equation. In the perpendicular direction, the forces must be equal. Net force must be zero. In this question, there are two forces here. N in the upward direction, mg in the downward direction. But the net force has to be zero. If the net force has to be zero in the perpendicular direction, the black direction, the vertical direction in this case, what is the equation that I'm going to make in the vertical direction or the perpendicular direction? And the answer is very simple. And the answer is simply N will be equal to mg. That was never asked in the original question, but you must understand that we have now completed the entire process of solving this question in circular dynamics. We have drawn the free body diagram. At first, I only drew tension because I knew that N and mg are not required, but you don't do it. Now you also know that in this question N and mg are not required, so you can also skip it. But that is not how you do it actually in your board exams or in your class school exams. Draw all the forces. N is upwards, mg is downwards, and T is towards the center. There is no force in the tangential direction. I don't have to draw it. So Ft is zero. The red equation is zero. In the green equation, we get the centripetal force. Centripetal force is given by the tension here. So T becomes equal to m into AC. AC is V square by R or omega square R. From there, you get the value of mv square by r. So T becomes equal to mv square by L because the radius of the circle is equal to the length of the string. Then I move on to the third axis, the perpendicular axis, the vertical axis. N is upwards, mg is downwards, N must be equal to mg. And that is how I solve the problem. Am I clear with this concept? I'll give you a minute to note this question down and I'll be back after a minute. I hope everyone has noted down the solution. The red equation, no equation in the tangential direction. Ft is 0. The green equation, in the centripetal direction, tension is equal to mv square by L. The black equation, in the vertical direction, there should be no forces. Forces should balance. N is equal to mg. Let us now move on and solve one more problem on similar lines. And I hope that you can do this problem on your own. So this is the challenge problem for you. For everyone sitting in the online class as well as in the offline class, there comes a challenge problem, and let us see if you all can do this. And here comes this problem. I hope you can do this. Again, the problem is happening on a smooth horizontal path. Instead of a string, we have a spring. Spring, not string. We have a spring. Let us go through this problem. A block of mass m. Let me also mark it on this sheet by my blue pen so that we can continue on the same thing. A block of mass m is attached to a spring of spring constant k, natural length L. The natural length of the spring is L. The other end of the spring is fixed at O. Block moves on a circular path, smooth horizontal surface, constant angular velocity omega. Find the tension. Now, sometimes you might find a question where they talk about tension in the spring. Don't worry. Tension in the spring simply means force in the spring, and force in the spring is always equal to kx, where k is the spring constant and x is the extension in the spring. So they're asking you to find out the force in the spring. You can also call it tension in the spring. I hope you can solve this problem on your own. I'll give you a minute to think about it. Well, as you can see, this question is pretty simple, on same lines as what we have done in the previous question. Again, this motion is happening on a circular path. We have to draw free body diagram. We have to draw all the forces, resolve them in three directions. Tangential direction, same question, there is no tangential force. Centripetal direction, there was tension in the string, here it is tension in the spring. The third one is the vertical direction, which will be the upward and downward direction. I have given you enough hints. This sheet is also there with you. I've shared it with you. I hope that you think about this problem. We'll discuss this problem in the next class. I'm giving it as an homework for you that you try it at home. I've already told you the hint. How do you find the force? You find the force by multiplying k with x. You know the value of k. You just have to find the value of x. How do you get the value of x? Well, you have three equations. Find it out. So I'm leaving you on this juncture that you will try this question at home and come up with answers. Put your answers in your Telegram group and I will be checking your answers there. Let's see how many of you try this. We'll meet in the next class. We'll be discussing this question and more questions, and we'll try to wind up the horizontal circle in the next class. I hope all of you would be doing this question at home and would be seeing this lecture once again, so that if there's anything that you have missed, you can always cover it up. In any case, I'm always available on the Telegram group. You can always get me there, ask your doubts. Any point in time I see your doubt, I would be responding back at that very moment. On this note, and again with the same lecture, stay at home, stay in your college, stay safe, get yourself vaccinated. That is what we can do right now. I'll meet you in the next class. Till then, take care. Have a nice day. Bye bye.